All right, today we are doing digit and coin problems. So the first type of problem we're going to do is a digit problem. It's going to look really confusing, but once you get it, it's super easy. They really never change. All right, here's the way the digit problem works. The sum of two digits is 11. If the digits are reversed, the new number is 27 more than the original. Oh. All right. So the first thing we're going to do, so we have to find the original number. If the sum of two digits is 11, the digits are reversed, the new number is 27 more than the original. We're looking for the original number. So the first thing we're going to do is we're going to say x represents, in this two-digit number, x will represent the tens digit. And if x represents the tens, then we'll make y to represent the units digit or the ones digit. You understand what I'm saying? So let's say I have a two-digit number, and it looks like this, and it looks like this. This is going to be my x, and this is going to be my y. Everybody's clear on that? Okay, so if that's the case, the original number, we don't know what it is, so we can call it xy, right? And what would the reverse look like? Yeah, yx. Okay, so the first sentence is very easy to translate because it's the sum of the two digits is 11. So what would that look like? A culprit? X plus y is 11, right? That's the first equation. Now, the second one's a little bit trickier, but it's always the same, and it's in your equation. It's in your word problem. So let's first talk about the value of that original number. The value. So if x is in the tens place, doesn't that mean 10 times x plus the 1? Right? 10 times x. That's the value statement. 10 times x plus 1y. Right? So what would the value of the reverse be? What would the value of the reverse be?
10y plus x.
Yeah. Are you guys understanding so far? So now here's what we're doing. The second part of it, we've already done. The first part we did here. Right? The second part is if the digits are, we start at reverse, is 27 more than original. So what is the reverse value? Reverse value.
10y plus x.
10y plus x. Actually, I think they're going to, if I do this, we'll get the word problem. Reverse is, and again, we're getting that right here, reverse is 27 more than original. So the reverse value, what did you say it was?
10y plus x.
10y plus x is?
27.
Is? What?
Equals.
27 more than original value. So, Ethan.
27 plus 11.
When I see more than, it's no, not 11. First of all, Natalia.
10x plus y.
Right, the original value is 10x plus y, and then we always put the original is here, and the 27 goes over here because it says more than. Okay, so we're not using 11, we're using actually these value statements in this second equation. Questions? I'm going to pause it to give you a chance to catch up on notes. All right, so the last question is, how did you get that 10x plus y and 10y plus x? So if I take let's say the number 23, okay, where are we getting that 2 from? If 2 is the x, aren't I doing 10 times 2 plus 3? That's the same thing as 10 times the x plus the y. And if I reverse it, I'm really doing 10 times the y, which is 3, plus the 2, which is x. So that's where we get these value statements, 10x plus y and 10y plus x. Yes?
So if you were to solve, you would get 10 times 2 plus 3, and that would equal 23?
Right.
Okay.
Wouldn't it? And this would be, what would this equal?
30 plus 2 equals 32.
Yeah. Because every tens digit right here is really multiplied by 2 times that 10. Okay? All right, so here we are. We said our reverse is 10y plus x, is the equals, and then the original is 10x plus y plus 27. So now you have two equations. If we have two equations, we can solve. What do you think the easiest way to solve is? Let's go a culprit.
Isolate the y in the number equation.
Y or the x, it doesn't matter.
I went with y, so y equals negative x plus y.
Negative x. But it doesn't matter what you isolate, you can just isolate either one. There's no benefit to either one. So if you get 11 minus x, we're then going to substitute that for every y that we see. Okay? So 10 times the quantity of 11 minus x plus x equals 10x plus what? 11 minus x. Because I have to substitute it again, plus the 27. Now, a lot of times I'll notice careless errors, people leaving off that 27 after they substitute. Or leaving off this extra x that's here after they substitute. So just make sure you're bringing everything else and not just substituting. Now we can distribute, combine like terms. We get 110 minus 10x plus the x equals 10x minus x makes what? I can combine my like terms. 10x minus x is
9x.
9x. And 11 and 27, 38. One thing you'll notice with these, you'll have a lot of 9x's. Okay, and now I can combine my like terms. Negative 10x and x is 9x. Negative 9x equals 9x plus 38. What am I doing? Yep. Adding 9x to both sides, subtracting 38. Divide both sides by 18. And x is equal to 4. So if x is 4, okay, I'm going to go back to either original equation, x plus y. I may as well just use this one right here. It's the same equation, it's just y equals 11 minus 4, so y equals 7. So what is the original number? What was the original number? Because this was a digit, yes.
47?
47 was the original numbers. Okay, questions? Okay, pause the recording if you want to take notes. All right. And these are always written the same way. Like, they don't really have much variety. So once you do it 3 or 4 times, it's like riding a bike. All right. What's my original number? Who remembers? What do we call it? What's the original number that we wrote? No, that's the value. That's the value.
XY.
XY. And reversed, what would it be?
YX.
YX. So x is my tens digit, y is my units digit. We always identify our unknowns. Okay, and what is my first equation?
X plus y equals 6.
Good. X plus y equals 6. Now, what am I underlining in here to help me translate the second part? Yes. Well, wait. What is the value of the original? Hold on, let's just put that on hold. What is the value of the original? The value statement? Good. And what is the value of the reverse? Yes.
10y plus x.
10y plus x. Good. So now, what are the words that I'm underlining?
Reversed.
Reversed.
More than.
before that?
Is
Is important.
more than,
More, keep going. What about 36? More than original. Those are the words that are telling us what to write. So what is the second equation? What do I write for reverse? Somebody else that I haven't heard from? How about Ted?
for a verse of, you would write,
Okay, I'll call on somebody. No, I've called on you. How about Natalie?
it would be the equation, yeah, so 10y plus x equals.
Hold on. 10y plus x is what I put for the reverse.
Yeah.
Ted, what do I put for is?
Equal.
Now I have 36 more than original.
So it would be
10x plus y plus 36. There are your two equations. Okay, is there anyone confused how to get that second equation? Okay, so now we are going to, we've got enough to solve. I want you guys to finish it. Pause the recording and finish. Okay, so I'm going to isolate my y. And what would I do with that? Layla?
Plugging the y in the bottom.
So it's going to read
10 times the quantity of 6 minus x plus x is equal to 10x plus 6 minus x plus 26.
perfect. And when you distribute, we get 60 minus 10x plus x equals 10x plus, and we can combine our like terms. 10x minus x is 9x. 6 and 36 is 42. Let's put our x's. We'll combine the like terms. It's 9x. 60 minus 9x equals 9x. Move the x's to one side. And what did we get? We should have gotten an x for the one, a 1 for the x, not an x for the 1, and a 1 for the x. And if x is 1, what is our y? Our y was 5. 42. If x is 1, I then go back to my original equation. Y equals 6 minus 1, y equals 7. So what was the... Sorry, 5. Always so good for the recording. Y equals... I was just seeing if you guys were awake. Okay, so what was my original number? The wooch. 15. So if you put it as 51, you would get that wrong. Okay, questions here. You ready to do one on your own?
Yes.
Okay.
Well, let's see.
Okay, whoops. Next one. Pause the recording and do the next one on your own. All right, so now let's check our work. Couple things are happening. Number one, I have people that are not listing, defining their unknown. This is not an option. This right here is not an option. The other, you should have notes for it. You shouldn't have to rewrite original number, value of. You shouldn't need to rewrite this every single time. But defining your unknowns, you should be doing every single time. So I have some kids that are not defining your unknowns, and that's a problem. So when they get the answer, they don't know if it's an X or a Y, and they put it in the wrong place. Number two, they're not making sense of it. They get a number, and they just place it as the X, not realizing if they solve for Y or for X. Number three, this is a huge problem I saw in multiple cases. I get this from here. Reverse is 9 less than original. So I get that from the problem. But I have people doing this. 10x plus y. What is wrong with that? What's wrong with that? Yes.
Well, it says that the new number is 9 less than the original, and 10x plus y is the original, so you have
What's wrong with what I just did, though? You're not telling me what I just did.
you have to do minus 9.
No. What's wrong? Let's go, Riley.
Because it needs to be the reverse, and that's the original.
This is the original, not the reverse. Do you guys understand that? I'm having people put the original first and then the reverse for the original. And then what happens is your digits get reversed and you end up with 67. So please make sure you're writing the reverse value when it asks for the reverse value. All right, the next type of problem, let's finish it up. Let's go on. You should have gotten 76. The next type of problem is a coin problem. Okay, so Mike has nickels and dimes. If the total of his 13 coins is $1, how much of each does he have? So I'm using the box for this. It should be pretty easy by now. Okay, I've got, and like for this, it's a quantity question and it's a unit question. So it's amount times what kind of units? Dollars equals a product. And then we've got, what are the two things we're comparing? Nickels and dimes. Okay, what are we calling the nickel? What are we calling the dime? Okay, do we know how many nickels? No. Do we know how many dimes? No. So we're going to say N and we're going to say D.
But we know there's the total is 13.
So if it's a total, we add another box. Right? And I'm adding 13 there. Okay? And then what is the unit rate of a nickel? This is a big one.
5.
It's not 5. Okay. Please make sure it's 0.05. I have a lot of people that actually write 0.5. 0.5 in money is 50 cents. So it's 0.05 or 0 and 500ths. Yes.
To make it 5 cents.
He's saying that multiply everything by 100.
Right, but after. Not now, of course. Later you're going to. But right now you're filling out information. What's the unit rate of a dime? 0.1. Okay, multiply across 0 and 500ths N and 0 and 1/10 D. And I'm going to go like that. Now, what else do we know?
Oh, that is the dollar total.
Okay, it's a total, it's $1 total. So I can write that as, I guess I'll just write 1.00 since I'm already in decimals. Now, what are my two equations? Nicholas?
M plus D equals 13, and 0.05 N plus 0.1 D equals 1.
Okay, so what do you want to do? What did you want to do, Dennis? Yes, of course you can do that. Because we don't like to deal with. So I'm going to do that, and my new equation will be 5N plus 10D equals 100. Okay? And now I've got, how do you want to do this? Do you want to...
Wait, hold on. You can also divide everything by 5.
Isolate these.
No.
I don't need to. I don't need to. It's just an extra step, Nicholas. What? We can do substitution or elimination. If I do this, if I go multiply by negative 10, then I get negative 10n minus 10d equals negative 130. Negative 10n minus 10d equals negative 130. I'm left with negative 5n equals negative 30. Divide by negative 5, divide by negative 5. N is equal to 6. I go back to my original problem. N plus D equals 13. 6 plus D equals 13. Subtract 6. I don't do things in my head. I use properties of equality. It's an algebra class. So I'm just not mental mathing. I'm doing everything. D equals 7. Okay? So I have 6 nickels and 7 dimes. Okay, questions? Does this seem easier than before?
Yes.
And it's kind of easy. It's like the same type of questions we were doing in 8-4. Can I move the information? Okay, we could have done substitution. Oh, they did it like this too. I go with multiplying by tens because I'm so easy, I can do mental math. Okay, why don't you guys try the next one? Go. Put it on pause and do the next problem. Okay, let's check our answers. So, I personally like elimination for these because I like things with 10. That makes things easy for me. Right away, if I'm multiplying everything by 10, right, I can do, and just multiply that first equation by 10 and then do elimination. So then I get 15q equals 195, divide by 15, and q is 13. If I have 13 quarters, then we substitute in, and we have 6 dimes. All right, last type of problem, which is, again, a review of what we were doing there, ticket problems. Again, we're going to go amount times the dollar value or the unit rate equals the product. What are we comparing? Matinees to regular movies. Do you guys even know what a matinee is?
Yes.
Matinee is the first show of the day. They used to make it like half price. For your 11 a.m. Yeah, it was like the early, when I was a kid, they called it the early matinee, and you'd get in for like half price or 25 cents. Gone are those days. Gone are those days. A movie theater sells matinee tickets for $5 and regular admission for $6.50. If 195 tickets were sold for total revenue of $1,110, how many of each type were sold? So, what am I putting under matinee? What are we putting under matinee? How about M? What are we putting under regular? Good. What is the unit rate of a matinee?
5.
And the other one?
6.50.
650. Multiply across, what do we get?
5M, 6.5R.
Okay, now, stop. What do I put at the bottom here?
195.
1100.
Okay, and we have 11. Shh, excuse me. Okay, so now my two equations are M plus R equals 195. And the other equation is 5M plus 6.5R equals 1110. Now listen, guys. This one, because it's not so easy and there's no tens, I might do substitution. I can still do elimination, but on anything that ends with a 10, that's an easy one for me. It's such mental math. And when you, now, All right, so now if we solve for Y, we get 90 tickets for Y. That means how many for the matinee? Yes, 105. Okay, are you remembering how to do the ticket problems?
Yeah.
Very similar to what we were doing in 8-4. That is the end of the recording. Tonight you're doing 8-6, 390, 390, 1 through 14.